Hello everyone, my name is Amar Kumar and my topic is best split for categorical attribute using information gain. So the question is, for the given dataset, identify the best attribute for the first split for constructing a decision tree classifier using information gain. As you see here in our dataset, we have mainly four attributes: temperature, headache, nausea, and flu. And flu is our target class attribute. And yes and no, we have two classes, yes or no. For temperature, we have high, very high, normal as categorical values, and for headache and nausea, we have yes or no, two binary categorical values. So finding split for constructing a decision tree, we are using entropy as a criterion here. So the steps are follows as follows. First step is find entropy for class attribute, and so in first step we calculate entropy for flu. Yeah, and then we find entropy and information gain for each attribute individually. For temperature, headache, and nausea, we calculate entropy for temperature, headache, and nausea on flu. Then we find the attribute which is giving maximum information gain and use that attribute for splitting our decision tree. So for this we are using entropy and information gain. So the formula for entropy is and E of D, where here D denotes the data set. So the entropy of D data set is negative summation of probability of class I into log of base 2 probability of class I, and the range goes from I1 to N, where Ci is the class level and N denotes the total number of class levels. So for flu, we have two class levels, yes and no. So that N is 2 in our case, and Ci are yes or no. So and we use entropy in our information gain. So information gain on X from Y is entropy of X minus entropy of X on Y, where X is the parent class and Y denotes the splitting attribute. So first step we find entropy for flu. So for entropy for flu, we calculate probability of class X, yes, and probability for class no. So for finding probability of class yes, we count yes class in flu 1, 2, 3, 4. We have 4 yes class out of 8 attributes, 8 tuples. So the probability of yes is 1 by 2. Similarly, probability of no is 4 by 8 is equal to 1 by 2. So the entropy is minus probability of yes, which is 1 by 2, log base 2 into probability of yes 1 by 2, minus 1 by 2 into log base 2 probability of no 1 by 2. So the values are 0.5 plus 0.5 is equal to 1. So the entropy of target variable is 1. When the entropy is 1, the attribute having maximum impurity or maximum disorder. Now we calculate information gain at all splitting attributes. For temperature, we have high, very high, and normal, 3 categorical values. So we calculate entropy for all 3 categorical values on flu. So first we fill contingency table. So when temperature is normal and target class flu gives yes, we have 0 values. As we say here in dataset, we have temperature is normal, when temperature is normal and flu yes. So normal yes, no, no. So 0 values. Then we check when temperature is normal and flu gives no. Normal no 1, normal no 2, normal no 3. So 3, we fill 3 here. Similarly for high and very high. After that we calculate entropy flu when temperature is normal. So for we have 3 tuples when temperature is normal. Out of 3 we have 3 no values. So probability is minus 3 by 3 log base 2 3 by 3. So probability of class no when temperature is normal is 3 by 3. So entropy of flu when temperature is normal is minus 3 by 3 log base 2 3 by 3. We are not considering the yes case, because here 0, we have 0 tuples for yes class when temperature is normal. So for when we calculating probability, so 0 by 3 is automatically 0, so we are discarding that. After calculating this, we get 0 as entropy, because log base 2 3 by 3 gives 0 value. Similarly, we calculate entropy for flu when temperature is high. So we have 2 yes classes for temperature high. So out of 3, 2 plus 1 3. So minus 2 by 3 log base 2 2 by 3. And we have no class for temperature high. So out of 3, so 1 by 3 log base 2 1 by 3. After solving this, we get 0.39 plus 0.53, which is as 0.92. After that, we calculate entropy for flu when temperature is very high, which is yes or very high. So minus 2 by 2, 0 plus 2 2, minus 2 by 2 log base 2 2 by 2, and no have 0. Similar case of normal yes, so we are discarding that. And after solving this, we get 0, because log base 2 1 is 0. After that, we calculate overall entropy for temperature, which is weighted average of all these three categorical values. So the weighted average is entropy of flu for temperature is equal to 3 by 8. 3 by 8 for normal. We have 3 normal values out of 8 rows. So 3 by 8 into 0, because entropy of this is 0, plus 3 by 8 into 0.92 plus 2 by 8 into 0 is equal to, after solving this, we get 0.345. Now we are using this weighted average in information gain. So information gain on flu from temperature is equal to entropy of flu minus weighted average, this entropy of flu on temperature. So 1 minus 0.345 is equal to 0.655. So information gain is 0.655. Here entropy of flu is 1, which is previously calculated in previous slide. Here this. After that, similarly, we calculate entropy for headache. So entropy for flu when headache is yes is minus 3 by 5, 3 plus 2 by 5, 3 plus 2 which is 5, so minus 3 by 5 log base 2 3 by 5. This is for when headache is yes, and for when headache is yes and class gives yes, and the entropy when headache is yes and class is no is minus 2 by 5, 2 out of 5, 3 plus 2 5. This, after solving this, we get 0.44 plus 0.53, which is 0.97. Similarly, we calculate for entropy for flu when headache is no, 1 by 3, 1 out of 1 plus 2 by 3. So this is for when headache is no and value is yes, and this is for when value is no and when class is no and headache is no. After solving this, we get 0.53 plus 0.39 is equal to 0.92, and weighted average is entropy of flu or headache is 5 by 8, because we have 5 yes values, 3 plus 2 5 yes values for headache, into entropy of headache, entropy of flu when headache is yes is 0.97 plus 3 by 8 into 0.92 is equal to 0.9512. Then we calculate information gain. Information gain of flu, information gain on flu from headache is equal to entropy of flu minus entropy of flu on headache is minus 1 minus 0.9512, which is 0.04875. Similarly, if we calculate for nausea, so entropy for flu when nausea is yes is 1, and entropy of nausea when entropy of flu when nausea is no is also 1, because we have two yes values and two no values, and total four values. So 2 by 4 is 1 by 2, and 2 by 4 is 1 by 2. So the values are 0.15 plus 0.5, which is 1. Similarly for this case 2 2. So the calculation is same for this and this. After finding weighted average, we have 4 for yes and 4 for no class. So 4 by 8 and 4 by 8 is 1 by 2 into entropy of this 1. 1 by 2 into 1 plus 1 by 2 into 1 is 1. And information gain on flu from nausea is equal to E into flu plus minus entropy of flu when nausea. 1 minus 1 is 0. So as we get information gain for all those, we see that we have highest value for information gain on flu from temperature. Since information gain from temperature is maximum, so it is selected as first splitting attribute.